Hello, in this video we will solve second order differential equations using the Cauchy Euler method, and this is going to be a shorter video. So yeah, we're doing second order differential equation, Cauchy Euler equation. So in this video we're going to have a non-constant coefficient where we can bring it down to a constant coefficient method where we write the characteristics equation. A Cauchy Euler. So how do you know if you can use a Cauchy Euler equation? So you can use it if it's in the form of this, uh, in a form like this: ax squared times y double prime plus b times x times y prime plus c times y equals 0. So if you look at it very carefully, what do they all have in common? This is a good clue that you can only use Cauchy Euler method if see how you have an x square and then a second derivative. So the power must match. That's how you know you can use a Cauchy Euler equation. So this is a power 2, this is a second derivative, this is a power 1, this is the first derivative. This is a constant, which is really just a 0. Has a constant usually has a power of 0, and then this is also a 0. So the power must match. That's how you know you can use the Cauchy Euler equation. So to solve for this type of differential equation, we plug in y equals x raised to the r and solve the characteristic equation. But in doing so, we do discover an awesome formula called the Cauchy Euler equation. So it would be, this is the Cauchy Euler equation, r squared. So once you determine that you can use the Cauchy Euler equation, uh, you figure out your b, you figure out your a, and figure out your c. And the b is the coefficient of x1, and your a is the coefficient of right next to the x2. So this is kind of review. If you recall, if you have real distinct roots, like we're different r's, you're going to set it up like this: c1 y equals c1 times x raised to the r plus c2 x to the r2. If you have repeated roots like this, your equation is going to be y equals c1 times x raised to the r plus c2 times x raised to the r times ln of x. So this is if you have a repeated root. And then if you have complex roots, it would be this: y equals c1 x raised to the alpha times cosine of ln x raised to the b plus c2 times x to the alpha times sin of ln of x beta. Okay. So this is kind of like review. Recall general formula for homogeneous second order differential equation is this. It's just what we went over. So if you need to copy that, go ahead and copy. Okay, now let's do some examples. So now you know when you can use it. So let's see if we can do example 1. Find the general solution to the differential equation. And this is just review. So the question is, we have x squared y double prime minus 3x y prime plus 3y equals 0. So can we use the Cauchy Euler equation? Uh, yes or no? I'm going to say yes, because the powers match, right? X squared second derivative, both of 2. X1 first derivative, yes. Constant and a constant, or 0 to 0, yes. So we can definitely use Cauchy Euler. Then what I would do is figure out our A, B, and C. My A is 1. It's the coefficient of x squared. My B is -3, right? It's the coefficient of x prime. And my C is the coefficient of y, so it's 3. Okay, so we determined it. We can use Cauchy Euler, figured our A, B, and C. Now we're going to plug it into the Cauchy Euler equation. So I'm going to plug it into here. So this is what we're going to plug it into, and we know our b and our a, so we're good. So it's going to be r squared plus b, which is -3, minus my a, which is 1, times by r, plus c, which is 3. And then kind of like clean this up. So this is going to be r squared, -3 minus 1 is -4, times by r, plus 3 equals to 0. So that's really like saying r squared minus 4r plus 3. Okay. Can we solve for r? I believe so. We could just factor this, just simple factoring, right? So this is going to be r, and what two numbers multiply 3 and when added gives you -4, -1, and -3. Okay. So, so yeah, and when you solve for r, your r value is going to be 1 and r equals 3. Okay, there are two distinct roots, right? These are two distinct real roots. So when we have two distinct roots, we put it in the form of this. Okay, so if it's two distinct roots, we use this equation. And then, so my R1 is 1 and my R3 is 3. So my final equation is going to be y equals C1x and my R1 is 1 plus C2x and my R2 is 3. Okay, so this is your final answer. Pretty simple, right? Okay, let's move on to a second problem. So same directions, find the general solution to the differential equation, and we have y equals, whoops. So the second one is, so where did I even write it? No, it should have been here. So the second problem is this. Okay, so we have x squared y double prime minus 7xy double prime plus 16y equals 0. So first step is figure, can we put it, can we use a Cauchy Euler equation? So let's look at our power. X squared, second derivative, good. X1, first derivative, good. Constant and a constant, or 0 to the 0, yes. So we definitely can use the Cauchy Euler method. And I'm going to figure out my a, b, and c. So my a is the coefficient of x squared, which is 1. My b is the coefficient of x, which is -7. And my c is the constant, or the number in front of y. Okay. Then once you figure out you're going to put it in r squared plus b minus a raised to the r plus c equals 0. It's going to be r squared plus, and then b minus a, so my b is -7, minus my a, which is 1, times it by r plus 16. Okay, it's going to be r squared plus -7 minus 1 is -8, r plus 16. And okay, so now can we factor this? Yes, we could try just doing simple factoring. And we factor this out. This is going to be r. What two numbers multiply 16 and when added gives you -8, -4, and -4, right? So you get r equals 4, and r equals 4. So you get a repeated root. So what happens when you have a repeated root? You are going to use this form. So if you have a repeated root, you're going to use this form. Okay, so it's just going to be, so our final answer is going to be y equals c1 x, and then my r is 4 plus c2 x 4 ln of x. Okay, so that's that one. Pretty straightforward, right? Not too bad. So let's move on to another example. So find the general solution to the differential equation. We have x squared. We have x squared y double prime minus xy prime plus 5y equals 0. So can we put it in the Cauchy Euler equation? Let's look. X squared second derivative, same power. X1 first derivative, 0 raised to the 0, or constant, yes. So then I would figure out my A, B, and C. So my A is 1, right? It's the power coefficient of x squared. My B is, yes, -1. It's the coefficient of the x, 1. And then my C is the 5. Okay, then we put it in the form of r squared plus b minus a times r plus c. This is 0. So that's r squared plus b minus a. So my b is -1 minus my 1, because my a is 1, times it by r plus c, which is 5. So that's going to be r squared plus -1, and -1 is -2, r plus 5. So that's going to be r squared minus 2r plus 5 equals to 0. Go ahead and factor this out. This is going to be r. What two numbers multiply 5 and when added gives you -2? Oh gosh, it's impossible, right? It's not, it's impossible. You can't find two numbers that multiply to +5 and when you add it gives you -2. So now you're just going to have to use the quadratic formula. So it's going to be r equals not x, because that's our r. Our r is our x, opposite of b. So my b, well, it's my, wait, so my a is 1, my b is -2, and my c is 5. So the opposite of b, so it's going to be minus a -2 plus or minus root b squared. B, if b is -2, b squared is +4 minus 4 times a. My a is 1 and my c is 5, all over 2 times a. Clean this up a bit. 2 negatives becomes a positive. 4 minus 4 times 5, that is what? 4 times 1 is 4 times by 5, that's 20, and then you have a -20. Oh no, looks like we have an imaginary root, which is fine, which is okay because we know how to deal with that. Yeah, so if we simplify this more, this is going to be 2 plus or minus 4 minus 20 is -16, all over 2. And if we clean this up a bit more, this is going to be 2 plus or minus. You can never have a negative in the radicals. That means you have imaginary roots, so that minus becomes an I, and then it's still 16. Okay, now it's getting easier. This is going to be r equals 2 plus or minus square root of 16 is perfect square, it's 4, so it's going to be 4i all over 2. And if you simplify this more, if you divide each term by 2, 2 divided by 2 is 1, plus or minus 4i divided by 2 is 2i. Okay, so what this means is this 1 is our alpha, and then this 2i is your b. So if you recall, if you have a complex root, which we have, we're going to put it in the form of y equals c1 x raised to the alpha times cosine of ln of x raised to the beta plus c2 x to the alpha sine of ln of x raised to the beta. Okay, so the next step is put it in because we have everything we need. So it's going to be y equals c1 x, and my alpha is 1 cosine of ln, and our ln of x, and our beta is not 2i but 2 plus c2 alpha raised to the power of 1 times sine of ln of x. Beta is 1, so that's not 1, 2. Sorry. And this is, I believe that's just your final answer. Okay, let's move on to another one. So same idea, we have x squared y double prime minus 2y equals 0. First step is, can we put it in the Wronskian, Cauchy Euler equation? We have an x squared second derivative, yes, but then we skip down to constant or 0 to the 0. What happened to our x1? So if you recall, if you're missing something, you can just replace it with 0. So we can rewrite this problem as x squared y double prime plus 0x 1 y prime minus 2y equals 0, right? Okay. Now we can definitely use the Cauchy Euler method. The powers matches. 2, 2, 1, 1, 0, 0. Good. So figure out, next I would do is figure out my a, b, and c. My a is the coefficient of x squared, 1. My b is the coefficient of x prime, which is 0. And my c is negative 2. Okay. The next step, what I'm going to do is put it in the form of r squared plus b minus a times r plus c equals 0. So it's going to be r squared plus, and my b is 0, minus my a, which is 1, times it by r, and then plus my negative c, or negative 2. And if you clean that up, that's going to be r squared. 0 minus 1 is negative 1r minus 2 equals to 0. Okay, factor this out. So this is going to be r, r. What two numbers multiply negative 2 and when added gives you negative 1? That's easy. That's negative 2 and plus 1. So my r is going to be positive 2 and negative 1. What can you say about these roots? They are very distinct. They're two different values, right? So our final answer, because they are distinct, it's going to be c1x raised to one of your r value, which is 2, plus c2x raised to one of your r value, which is negative 1. Okay, so that is your final answer. Let's do one more. So this is the last one for the Cauchy Euler method. Find the general solution to the differential equation. We have x squared y double prime minus 3x y prime plus 29y equals 0. So can we use the Cauchy Euler method? I think so, right? Because look at this is 2, 2. This is 1, 1, and then constant, constant, or 0, 0. So yes, we can definitely use the Cauchy Euler method. I mean Cauchy Euler equation. So then I would figure out my A. My A is the coefficient of x bar is 1. My B is the coefficient of x, which is -3. My C is the coefficient y, which is 29. Okay, step 1, put it in this form, r squared plus b minus a raised to the times by r plus c plus 0. It's going to be r squared plus, and then my b is -3 minus my a, which is 1, times by r plus my c, which is 29. So this is going to be r squared plus -3 minus 1 is -4r plus 29. Okay. Then what I would do next is figure out my a, b, and c. So my a is 1, my b is -4, and my c is 29. Okay. Uh, I don't think we can factor this, right? Right, we cannot factor this, so we'll have to use a quadratic. So this is why I put my a, b, and c. So my a is 1, my b is -4, and my c is 21. So you're going to use quadratic. Okay, so it's going to be r equals opposite of b, which is +4, plus or minus root, b squared, which is, if b is -4, b squared is 16, minus 4 times a, which is 1, and my c is 29, all over 2a. Okay, so that's going to be r equals 4 plus or minus 16 minus 4 times 1 times 29 is -100. And then you can't have a negative in the radical, so you take out an I. This is 4 plus or minus. The square root of 100 is perfect. It's going to be 10. And then you have an I all over 2. And then you just clean this up a bit. 4, divide each term by 2. So 4 divided by 2 is 2. Plus or minus 10i divided by 2 is 5i. Okay, so we have imaginary roots. So if you recall, this 2 is your alpha, and then this 5i is your beta. Okay, so now we put it in we're gonna put it in the form of y equals c1 x, and then my r is 2, so it's x squared cosine of ln of x, and then my beta is 5 plus c2 x2 sin of ln of x raised to the 5. And that's it. That's your final answer. So yeah, Cauchy Euler is not too bad. If you know you can put it in the form, if you know you can put it in the form of go up. So if you know you can put it in this form, you know you can use Cauchy Euler equation. Okay, I'm gonna stop here. Okay, thank you.